So today we are working on Keikoh's art video, and we want to answer the question of why, when there are 6 dots on a circle, why it only breaks up into 31 sections. So we noticed that if we have a full circle, which I haven't drawn on here yet, if we were to put 0 dots on a circle, it's just a full circle, how many colors would we need? How many sections would it break up into? Because however many sections we need, it determines how many colors we need. So if we just had one whole circle, we would know it only use one color. So what we do know is that if we add 2 dots on a circle, 2 dots connect with one line, and that means it breaks up into 2 different regions, okay? So we know that we would need 2 different colors. So now what about if we add 3 dots on a circle? The goal is to connect a dot to a line with a line from all of the other dots on the circle. So if for example, if I was using this dot, I would want to connect it to this dot on the square, as well as this dot on the square, okay? As well as these 2 dots are already connected, so we want to connect these 2 as well. So we notice that it has 3 different lines, but how many sections do we have? We have 1, 2, 3, 4. So what would happen if I broke it up? If we had 4 dots on it, well, we want to connect it to all the other dots. So we have this dot here, we're trying to connect it, so it would be 1, 2, 3. There should be 3 lines coming out of each dot. So once we connect all the dots, we notice that there are 8 sections. Well, we kind of notice a pattern that 2 times 2 is 4. 4 times 2 is 8. So can we guess what the next section would be? Yeah, 5 dots. And if we continue with the pattern, we would know that the next circle for connecting each dot with all the other dots, this should have 4 lines coming out of it based on there's 4 other dots in this circle. And we know that, yes, there are 16 colors Keikoh would be using. So now we get to number 16, or number 6. And what can our guess be? Our guess would be that after connecting all of these dots, we would have 32 different sections, so she would need 32 colors. But we realized that she only needs 31 colors. And why is that? Well, that all comes down to the part of that when we are doing these sections, without realizing it, we are naming these sections, okay? So each of these sections has a name. And our goal is to name each section, but we want them all to have a different name because, right, we don't want 2 sections to have 2 names. That would get confusing. So how we name sections is we probably should learn the rules first. So we know that this is our method. These are our rules for how we name each section. We look at the lines that form the boundary, okay? And then we only look at the lines that go to the biggest value. That connects 2 lines at the region. So we look at the biggest value that has a connected line. On those lines, go from the smaller number to the bigger number and use the one that has the region at the right. And then our final step is look at the vertex closer to the smaller value on the segment, okay? So now what we want to do is we want to figure out, based on what the circle is broken up to, how many sections there would be, or how many different names there would be. So we need to know what we are going to name each of these dots, because we are going to have a circle with 6 dots, because we are trying to figure out why there are only 31 sections and why it kind of breaks the pattern. So what we realize is we have 1, 2, 3, 4, 5, and then a dot named no name. Well, why do we call it no name? We call it no name because based off of our rules, when we connect a line to a line, the smaller line to the bigger line is going to give us that name. So if we connect line 1 to line 5, we know that this region would be called 15 because it's the region to the right of the lines, and we go from smallest to biggest, so it would be 15. Well, okay, so then what happens when we want to just have a single digit number? If we always are connecting 1 to another number, we are going to get double digit numbers. So that's why we have a dot called no name, because if we have it connected to no name, then that is essentially like 0, but it's not. So if I am connecting 1 to no name, well, 1 is the greater value, or 1 is the lesser value, and so this region would be called 1. So basically, we have an equation for that. Or I guess I should not say it's not an equation, but we have a reason for why there are only 31 lines and why we have to have a spot called no name. So basically what we know is that if we have a number connected to no name, it's only going to have 1 digit and 1 line. So we know that any number connected to a no name is going to just have 1 digit. So we want to figure out what other combinations, because we want to know as many combinations of regions and numbers that could, and names we could have, depending on how many numbers we have. So now if we move up to 2, we know that if we want to have 1 digit in each region, only 1 name, we know that there are 5, and we know that there are 5 based on because point number 1 can go to no name once, point number 2 can go to no name once, point number 3 can go to no name once, point number 4, etc. And that would mean 5 total, 5 dots. So that makes sense. So now if we were to do the same with 2-digit numbers, we know that there are a total of 10 combinations that we could do. Okay? And that is the same with 3-digit combinations. There would be 10 we could do again, and then for 4-digit combinations, we know that there would be 5 based on if there were 6 dots on a circle with no name included. So we know if we add up all those combinations, it would be 5 plus 10, which is 15, 15 plus 10, which is 25, 25 plus 5, which is 30, 30 plus 1, which is 31. So essentially, we know that because of the rules that we've been following, which I showed you earlier, because of those rules that we have been following, we know that based on the number of regions, in order for there to be no duplicate names, when there are 6 dots on a circle broken up into regions, there could only be 31 regions. Therefore, Keikoh would only need 31 different colors. We also know that that same reasoning and same kind of idea that we did with the 6 dots would work if there were only 5 dots around the circle, and that's why only 16 colors would be used. And then the same would be with 4 dots, and that's why there are only 8 colors that would be used. And then that's the same with 3 dots, which is 4 colors, 2 dots, 2 colors. So you could use it for all of as many different dots there are on the line. You can use kind of the same idea that we did with the Keikohs, with the 6 dots on the circle. So if you wanted to try that out, you can continue to do that, and that will show you why we are able to get all of those other colors, even though they're a little bit easier to see just from drawing out. But thank you.